In this last lesson of the chapter, we're going to be looking at comparing linear, exponential, and quadratic functions. So just to remind you, remember, a linear function is this y equals mx plus b when we have a straight slanted line, right, going up or down from left to right. Our exponential function is when we have x in the exponent. So remember, that's when we have an asymptote, so it doesn't hit a certain horizontal line, and it makes kind of this L-shaped curve. And finally, the big focus of this chapter was on the quadratic function, which is our parabola. So we want to be able to tell when we have what kind of model and go from there. So let's look at the first example, which should hopefully be pretty straightforward. All we're going to do is we're going to plot these points and then say, does it look like it fits the straight line, the linear, the L curve, which is the exponential, or the U curve, which is that quadratic. So all you're going to do is go ahead and plot your points first. So let me go ahead and plot my points for A. And it's okay if, for these given coordinate grids, if it's going off the graph, it's okay. If you have enough space to estimate it, go ahead and do that, or just ignore the one or two that don't fit. And when you're looking at A, hopefully you're seeing what I'm seeing, and I'm saying, wait a minute, kind of looks like it fits straight line. So I'm going to go ahead and see if that works. So that's where you need to pull out your ruler and try to line that up. And since I'm using my tablet, not my ruler, what I'm going to try to do is I'm going to try to make a straight line that goes through these points. And let me just move that down a little bit. And, well, it's not cooperating with me, but it should actually hit on a straight line. So because it should, let me see if I can make that a little bit better. And there we go. So you see how that fits my straight line? Then I'm going to go ahead and call this a linear function. Okay, I'm going to go ahead and do B, and let's see what we think we get. So I had to go up a little bit to make that 6 happen, but what does this look like? Well, hopefully you're seeing it's mirroring each other, right? And between the points, we don't have a common slope, so this is what we're going to call a quadratic. Okay, and let's take a look at C. And that final one should have been 1 and 1.5. So what does this look like? Well, I'm thinking it may be quadratic, but the problem is I don't see it curving back up. So when I look at this curve, the best thing I can say is it looks like it's creating that L shape. So I think from what I see right now, my best bet is saying it's exponential. Okay? Remember, you don't always have to have one of each. You just go with what you know, go with what you see, and let's try that out. So go ahead and try 1, 2, and 3 for me, and let's see what we get. So go ahead and check. So here we happen to have one of each, but remember, it doesn't always have to work out that nicely. So quadratic, exponential, and linear. Remember, if you have questions, please come back to class with those questions. Okay, so now we're going to look at writing functions to model data. So this is where things can get a little tricky because we have like what we call first differences and second differences. So let's talk about what these mean. So when we're talking about a linear function, the first differences are constant. So what do we mean by first differences? Well, first differences are the differences of consecutive y values. So we're just looking at, subtracting y values from each other. So you might be looking at, y2 minus y1, y3 minus y2, etc. Okay? Exponential functions are usually a little simpler for me at least to find because we're looking for a common ratio. So that means we're multiplying or dividing the y's by some number. And here's where I think things will get a little tricky is with the quadratic, we're talking about what we call the second differences. So the second differences are what we're going to do once we have the first differences. So we're going to take the differences of the first difference. And this will be a little clearer when we get to the example that uses that second difference. But remember, no matter what, all of the x's need to have a common difference. Okay? And usually that's going to be a 1. So if we take a look at D, double check that the x's are growing or increasing or decreasing by the same value. So here, -3 plus 1 is what gives me -2. -2 plus 1 is what gets me -1. -1 plus 1 is 0. 0 plus 1 is 1. So x's check off. So no matter what, the x's are going to be either added or subtracted by the same number. So what I like to look at first is to determine if it's exponential first. So I might look at 4, 0, -2, and 0 and think, well, can I divide by anything to get these numbers? Well, whenever I see a 0, I'm going to think, no, there's no way I can divide 4 by anything to make 0. So I know it's not exponential. Okay? So then what I want to do is I'm going to look at the first differences to see if it's linear. So the first difference is when you're thinking about, well, what did I do to go from 4 to 0, right? What do I do to go from 0 to -2, etc.? So it doesn't really matter which way you go. And actually, let me erase that because I'm going to go y1 minus y2 and so on. So I'm going to go y1 minus y2, y2 minus y3, etc. So I'm going to go ahead and go, well, 4 to 0, that's a -4. 0 to -2, well, that's a -2. -2 to 2, well, that was 0. -2 to 0, well, that's a +2. So those are what are called the first differences because I'm subtracting the y's from each other. And notice there's no pattern here. So when there's no pattern, I want to say, well, let's check the second difference. If there was a pattern, I'd stop and say, okay, that's linear. But because there's no pattern, I'm going to check the second difference. So now instead of going back to the original y's, I'm going to look at these new first differences and say, well, what do I do to go from -4 to -2? Well, I added 2. What do I do to go from -2 to 0? Well, I also added 2. What about 0 to 2? Well, hey, look, I also added 2. So now these second differences are the same, which means this is quadratic. Okay? So that's the difference between first and second difference. All right? So let's go ahead and take a look at E. So once again, double check the x's, and the x's here look great again because I'm just adding 1 every time. Here I might say, okay, let's check out the ratio. Is there anything I can multiply to get from 6 to 8? Well, I might say, okay, 6 times what equals 8? So I might think, okay, well, 6 times some value equals 8. I'm going to go ahead and solve that equation. Oops, that should be 6. So my x was 8 over 6, or 4/3. So now I want to check, well, does 8 times 4/3 equals 10? Well, 8 times x should equal 10, so divide by 8. And no, that's not going to work. So it's not exponential. So I'm going to go ahead and scratch that out. Because again, I like to check for exponential first. And then I'm going to go ahead and check for the first differences and see if there's a pattern. So 6 to 8, +2. 8 to 10, +2 again. 10 to 12, +2. 12 to 14, +2. This looks great. So since I already have a pattern, I'm going to stop here and just call this linear. Okay? Finally, take a look at F. Remember, always double check real quick if the x's work. And this, again, looks awesome because I'm adding 1 every time. And then, again, I like to double check the ratios. So I want to think, okay, 0.5 times some value equals 3. So x equals 30 over 5. So x equals 6. Oh, what am I saying? Okay, that's 0.5 to 3. Then 3 to 18. Does 3 times 6 equal 18? Yes. Then I want to check this one. 18 times 6, does that equal 108? Well, 108 does equal 108. Yes. And finally, this last check, 108 times 6, does that equal 648? And trust me when I say yes, it does equal 648. So that's how I know this is exponential, because I multiplied every y by 6. Okay? So go ahead and try out 4, 5, and 6 for me and tell me if it's linear, exponential, or quadratic. All right, so we should get linear, quadratic, and then exponential. Oops, that's a really messy quadratic. So you might be wondering, wait, Miss Huang, what about this then write the function? We're going to actually do this in class. So what I wanted you to make sure you went over in the video first was determining which one we had. Okay? So please come back with questions and we'll again write these functions and finish off the notes in class. Thanks for listening.